This is Daniel Coosbury, and in this video, I'm going to show you how to do a two-sided test for the population proportion P. So we've got some kind of population we're interested in, and we're interested in finding the proportion of things or people who fall into some sort of category, and we call that P. So we're looking for this thing right here. And usually we have a simple formula for like computing a proportion. So we usually mean P is the number of people in a category, or the number of things in a category, which we denote with an S, X, and you divide by N, which is the sample size. So X is the number of items in category, or people or something. And N is the total number, the sample size of things. And frankly, if we're talking about a population proportion, this means that we're not actually using sample size, we're using the population size. So you have a whole population, and you take the number of items in the category, divide it. That gives you your proportion. So proportions are between 0 and 1, and we want to estimate for this. And the best thing we can do is to start by taking a random sample and compute the sample proportion, which is found in a very similar way. You take the number of items in a category, divide by the sample size, which is little n. So we're going to use the sample proportion to estimate for the population proportion, and we're going to form a hypothesis test that'll work for any case for the population proportion. So let's start by testing this claim. Trident claims that 4 out of 5 dentists recommend their chewing gum. In a random sample of 50 dentists, 35 of them recommend Trident. Can we reject Trident's claim using alpha equals 0.10 significance level? So we're testing the age-old tale that 4 out of 5 dentists recommend Trident. This is our sample size. And we can find our sample proportion as well. But let's start with the hypothesis. So hypotheses are going to be, one of them's got to be P is equal to something, and the other one is P is not equal to, or P is greater than or less than something. So the claim we're testing is 4 out of 5 dentists recommend chewing gum. So the proportion of dentists that recommend chewing gum is 4 out of 5, or how about we do 80%, 0.8. We can do that. So this is the proportion. Maybe this is worth defining. This is the true proportion of dentists who recommend Trident. The true proportion, the population proportion. And the question is this claim true? So why don't we do a two-sided test this will be the claim's not true. So either it's true or it's not true. We're not necessarily looking at more dentists recommending it or less. We just want to test this claim that 80%, 4 out of 5 dentists recommend Trident. And we're told to use a significance level of alpha is equal to 0.10. So we're going to use that without question and go on to the test statistics. So for the population proportion, the best estimate we have for it is the sample proportion, which is p hat. And the central limit theorem tells us that p hat has a normal distribution with mean p and a standard deviation of this thing. So we've seen this before with the central limit theorem. So if we use the z-score formula, where you take a normally distributed thing, subtract its mean, and divide by its standard deviation, you get something that is normal 0, 1, or something that's standard normal. So we're going to use the z-score formula here. Take the normally distributed thing, that's p hat, subtract its mean, which we're going to call p naught, that's the mean under the null hypothesis, and divide by the standard deviation under the null hypothesis, which is this thing right here. So we're subtracting the mean, divide by the standard deviation, and we get something that follows the standard normal distribution. So in this context, our h naught is that p is equal to 0.8. So our p naught is going to be this number, 0.8. It's p under the null hypothesis. So those zeros kind of match up. So in this example, we need our sample proportion as well. So we saw that out of 50 people that were sampled, 35, I'm sorry, not people, dentists. They're people too, but specifically dentists. 35 out of 50 dentists, or 0.7 dentists in this sample recommended Trident. So we'll plug in 0.7 for p hat. We'll plug in 0.8 for p naught. So 0.8 goes there, there, and there. and our sample size is 50. So we sampled 50 dentists. That goes down there. And if you do all this in your calculator, you get negative 1.77 as your test statistic. And note that Z follows the standard normal distribution. So we're about to do the critical region things and the p-value things, and they're going to come, their distribution is going to be standard normal. So we're going to put this on standard normal bell curve. So let's start with a critical region. We're asking if p is equal to 0.8, is it unusual if our test statistic is at least as extreme as 1.77? And we're doing a two-sided test now. So extreme means as far out left or as far out right as kind of the opposite of that. So the critical region is going to be two equal sized tails whose area totals 0.1. In other words, we're going to find a tail over here and a tail over here, and their areas combined should be equal to, I think I put those a little too far. Let's put them right there. And their areas combined are going to be equal to 0.1. So that means this area has to be 0.05, and this area also has to be 0.05. So that's going to be our critical region. So then there's a value here, we'll call it Z.05, that marks off this upper 5%, and the opposite of that number marks off the lower 5%. And we can find this number using inverse norm. So Z.05 is equal to inverse norm. You can find either one, really. You can find the negative one or the positive one. So for the area to the left, for the negative one, put 0.05. Area to the left for the positive one, you can put 0.95. I'm already kind of ready to do 0.95. So you do that in your calculator. You do inverse norm. .9501. You get, oh, it's that same number, 1.645. So we've seen this before. So that means this guy is 1.645. This guy is negative 1.645. So that's this thing right here. That's this thing. So that's our critical region method. So what we mean by the critical region is if the statistic falls in this red shaded region, either one of these, we're going to say it's extreme. The chance of it happening is under 10%. And if it doesn't fall in the region, then the chance of it happening is going to be over 10%. So it's going to fall in the common 90%. So Z is equal to negative 1.77. So if this is negative 1.65, Z would be like right here. Negative 1.77. So that's our Z, which is in the critical region. Okay, so you can kind of see, there's the red region, Z just falls right in there. So Z's in the critical region, it's in this lower 5%. It's in this unusual 10% extreme area. So we can draw our conclusion. We've marked off a critical region such that any Z that falls within it has a 10% chance or less of occurring. So Z is equal to negative 1.77 falls within the critical region. The probability of its occurrence is less than 0.1. So we'll conclude it is unusual to get the statistic if P is equal to 0.8. That is, if H naught is true. If H naught is true, this is unusual. So we're going to reject H naught because it's unusual. So if H naught is true, this is unusual. We'll reject H naught because it's unusual. So if you're looking for a nice kind of way to summarize this, since Z falls within the critical region, reject H naught. That's a nice rule. That'll work for any hypothesis test. If you've made the critical region correctly and your statistic falls in it, you're going to reject H naught. So we're going to conclude we have sufficient evidence to reject H naught in favor of H1. That is, we can conclude the proportion of dentists who recommend Trident is not 0.8. So they're lying or they're wrong or this is antiquated or we can't say it's less than 0.8. We don't want to say it's greater than 0.8. We'll just say it's not 0.8. We have evidence to say that this is not the proportion of dentists who recommend Trident. Now let's do the other method. So the p-value method is an alternative to the critical region method. You can do either one. I'm just going to show you both. And so back up a few steps pretend that we haven't done the critical region method. We haven't drawn a conclusion yet. We just found the test statistic of being negative 1.77. The p-value is going to be the probability of getting a statistic that's at least as small as negative 1.77 or as big as its opposite. So the p-value starts off is this left tail and the opposite right tail that starts at 1.77. And this is the chance that you get something at least as extreme or more extreme than this negative 1.77. So what's the chance you end up super low or super high on the other side? The p-value is that probability. So the p-value is the probability that z is less than negative 1.77 plus the probability that z is greater than 1.77. So those two tails. And let's just agree that since these both have the same starting or opposite starting points, but they're related, let's just agree that they have the same area. And if we just find the area of 1, it can be done. So let's say this is equal to 2 times the probability that z is less than or equal to 1.77. So if I find this left region and double it, I have my p-value. Or you can find both separately and add them together, but I'm just going to double this one. So I'm going to use normal CDF in this case. Normal CDF for the left region. That means I'm going to start at negative 999,999, and I'm going to stop at negative 1.77. So that's the boundaries for the left region. It goes all the way to negative infinity, goes up to negative 1.77. My mean is 0, and my standard deviation is 1, and my area for that region is 0.038. You can round that to 4 if you want, but I'm not going to round it yet because my p-value is actually twice that number. So I just found this thing. Now I'm going to double it just to add the right region. So I'm going to take my answer, multiply it times 2, and I get 0.0767 as my p-value. So the area of both of these things is equal to that number, the total area. And that's my p-value. All the same thing. The p-value is those areas right there together. In other words, the chance of getting something at least as extreme as negative 1.77 is this, 7.67%, you could say. So we'll draw this conclusion. We found the p-value, which is the probability you're in the left tail plus the probability you're in the right tail, is equal to 0.0767, which is less than the significance level. So we could say that if p is really 0.8, that is, if h naught is true, the probability that we take a sample with a proportion at least as extreme as what we got is 0.0767. So we're going to reject h naught because our results have a 7.67% chance of occurring if h naught is true. And we said that anything that has less than a 10% chance of occurring if h naught is true is going to be extreme. And so we'll reject h naught because this is extreme in this context where we're calling unusual 10% here. This is less than 10%. So we're going to call this unusual, reject h naught. And we're going to conclude that the proportion of dentists who recommend Trident is not 0.8.